Abdul Rahman. I'm a lecturer at a public university in Kenya. I deliver lectures in computing and informatics. In our last lesson, we talked about pointer to strings, and we have seen that a string is an array of character because C programming doesn't have actually support string. So we have array of characters, and this particular array of character, actually the size of it is actually determined by what we call a null value, or that will be actually the end of a string. Today we are going to study and ask ourselves, what is a pointer called by value? And in that particular journey, we are going to discuss the definition, the concept, and finally we are going to implement it. So let us start on that particular journey and see what happens. So what is actually a pointer called by value? So a pointer called by value, actually we are saying it is actually nothing but it is actually a concept, and this particular concept is whereby a function actually accepts a pointer argument. So a concept whereby a function accepts a pointer argument, but this particular pointer argument accepts it only as what you call a value. Therefore, the value here we are talking about, it is actually the value which is inside an address, and it will be manipulated. However, an address will not be manipulated. So here we have got a value which is going to be manipulated. However, the address, it is unchanged. So the address will be unchanged. So that will lead us into the concept of it. So let's try to conceptualize, and let's say if we have a variable which has got a value of 10, and then we can say very comfortably that actually, and here we have got our pointer. So what you can say, our P can be assigned actually the address of X. So if we want to conceptualize the same, we can have here basically our X, which will have a value of 10, and hypothetically maybe have an address of 2020, and then here we'll have our pointer which will have, let's say, an address of 4050, and the value of this particular pointer, actually it will point to the address of X. So it will point to this address of X, and here we'll have our value as 2020. Therefore, if we have to output in a printf, so our output basically here we'll have our X to be equals to 10, and our P actually will get up our value 2020. Now, if we are going to change, let's take for example, we are going to change the values of X, and here we are saying X is equal to 10 and X is equal to 20, sorry. So let's take for example, we are saying X is equal to 20, and P, actually we are putting up a value of X. So what will happen here? What will happen is very simple. This value, when X is equal to 20, this value will change to 20, and from there, actually our x does not change to point 2. Our p does not change to point to the address of x, so it goes back here. So our output this time, after change, actually will have our x to be 20, while our p remains the same at 220. So basically this will be actually the concept. So let's go to the C++ and try to get up this particular concept. And basically here we are going to have some function. So here we'll have our function, maybe call this particular function void change, and this particular function will take up an integer pointer called p. So that is our integer pointer called p, and basically we'll have the opening and closing curly bracket for that particular pointer. So here basically we are having our int a, our value of a, and we are giving it a value of 10, and then we are assigning up our p, and we are assigning it to the address of a, and then we're putting up a print to print. So here we have got our printf, and here in our printf we are saying before change, so the value of a should be equal to, that is %d, and then we are having our tab, and then we are saying the address should be equals to, and then we have a format specifier for an address, which is %u, and then basically we want to access our a and our p. So here we'll see up the value of a and p before change. So now let us put up our change. So here we are changing now, changing up the value. So basically here now we are saying a equals to 20, and basically also now we are saying our p should be equal to, or we are passing it into a, and here again we are now trying to print again, printf, and here basically we are saying after change the value a equals to %d, and we're putting up our tab, and then we're having up our address equals to %u. And basically what do you have? We have our a and we have our p. So basically this is how you're supposed to demonstrate. Here you can put up equals to. Here actually we want to see, will actually the value change and the address remains. So here we actually calling up. So here we can say we are calling up our function t. So we say int x, and then here we are calling up our function change. Change actually the address of, because it's a pointer, the address of x. So let us run this particular program. So we have defined our function here and we are calling down here. So let's run this particular program. So when we run this particular program, we can see actually before change the value of A was 10. After change it has actually changed into 20, while the address remained actually the same, ending up with 64, and also after the change remaining up with 64. This is how actually we have demonstrated onto our concept of pointer by a value, whereby only we are passing up only the value, whereby the address remains unchanged. Until now, we are saying thank you, and we are coming up to the end of this particular program. However, don't forget to subscribe into our next program, whereby we are going to discuss pointer call by reference. Thank you.